In this video, we're covering scientific notation, sometimes called standard form. Before we define anything, look at this number. That's the kind of number you get handed in chemistry and physics all the way through this course. Writing it out in full every time is slow, and it's easy to miscount a zero. Scientific notation fixes that. Same number, written like this. Here's the definition. A times 10 to the k, where a is at least 1 but less than 10, and k is an integer, positive or negative. So the front number always sits between 1 and 10. And the power of 10 tells you how far the decimal point moved and which direction. A positive k means the number is large. A negative k means it's small. Now go back to the number we started with. The front number has to be between 1 and 10. So we put the decimal right after the 8. That gives us 8.2. Then count how many places the decimal moved. 9 places. And the number is large, so k is positive. 8.2 times 10 to the 9th. Example 1. Write 45 million in scientific notation. Put the decimal after the 4, which gives 4.5. Now count the places from where the decimal was to where it is now. 7. The number is large, so k is positive. 4.5 times 10 to the 7th. Example 2. Write 0.000032 in scientific notation. The front number has to be between 1 and 10, so we want 3.2. Count how many places the decimal moves. 1, 2, 3, 4, 5. But this time, the number is small. Less than 1, so k is negative. 3.2 times 10 to the negative 5th. Example 3. Now let's go the other way. Write 6.1 times 10 to the 4th in full. The exponent is positive 4, so the decimal moves 4 places to the right. 6.1 becomes 61,000. Notice you have to add zeros to fill the gap once you run out of digits. Example 4. Multiply 3 times 10 to the 5th by 2 times 10 to the 3rd. Handle the front numbers and the powers separately. 3 times 2 is 6. Then 10 to the 5th times 10 to the 3rd. Same base, multiplying, so we add the exponents. 5 plus 3 is 8. That gives 6 times 10 to the 8th. And notice, that's just the product rule from the last video. Last one. Divide 9.6 times 10 to the 7th by 3 times 10 squared. Front numbers first. 9.6 divided by 3 is 3.2. Then the powers. We're dividing, so we subtract the exponents. 7 minus 2 is 5. So the answer is 3.2 times 10 to the 5th. And you can check this on your calculator using the times 10 to the x key. 9.6 times 10 to the x, 7, divided by 3 times 10 to the x, 2. That gives 320,000, which is 3.2 times 10 to the 5th. It checks out. Scientific notation comes back constantly in chemistry, physics, and later in exponential functions. The next video moves into sequences, starting with the arithmetic kind.